right, so we're going to finish the tangent graph, right? And here's the issue. We went around our unit circle that we talked about doing, and it gave us this. It's not a very good picture, is it? Okay, so that doesn't help us out any. So we need to know what the graph looks like. I don't know what you guys remember about an asymptote, but at this spot, what I have actually is that pi over 2, okay, we have 1 divided by 0. And you're not allowed to be at divide by 0. So that spot won't have a point. It's undefined, right? X can't be 0. I'm sorry, the denominator can't be 0. So what happens is your graph is going to get closer and closer to this point, okay? And it's either going to go up like this. In fact, I can draw this. It will either get closer and closer to this, okay? Or maybe it will go down and get closer and closer this way. But it will approach that line. It'll get 0.9, 0.8, 0.7, 0.6, 0.5, 0.3. But it can never be 0, right? So now we have to decide which of these are true. Does it go up or down? And when does it go up and down? Well, how do we get the points that we already have? Where do we use them from? Where do we get them from? The unit circle, right? So let's look at tangents on the unit circle, and you show me, look at them. Which tangents look pretty? We've already used the zeros and undefines. Walk through your purple unit circle that you have, and tell me which ones look nice, which ones look easy to graph. I hear it already. We graphed this one. Now look here, between 0 and pi over 2, it's where are we going to stop here that's got a pretty tangent? Right here in the middle. So we're going to stop here. Listen to me so this will make sense. Halfway between 0 and pi over 2, we're going to stop, and what's the value going to be? 1. Okay, then we're going to know, all right, then we have undefined. Halfway between pi over 2 and pi, where are we going to stop the easy tangent? -1, right? Okay? And then what tangent are we going to use at pi? 0. And then where are we going to stop? What's another pretty tangent down here? Root 3, 1, root 3. Where's the pretty tangent? 1. How did I get 1 here? How am I getting 1? It's on your purple sheet, and I have it, but where did it come from?
Negative over negative equals positive.
Right. Y divided by x. Root 2 over 2 divided by root 2 is 1. Okay. Then I'm going to stop down here at undefined, and then here at -1, and back to 0. Okay? So this is what I'm going to show you. So between 0 and undefined, what pretty tangent am I going to graph right in the middle? This is yeah.
Okay.
You know what I meant. Yeah, it's the okay. So between 0 and pi over 2, I'm going to put a really little pi over 4 here because that's what we found. It's not necessarily necessary, but they're notes. So where are we right between here and here? We're at where? At pi over 4, what's our output? 1. Okay. Now look back at your unit circle. So look at what stops we've made. 0, 1, undefined. Let's check it. 0, 1, undefined. Y'all see what I'm doing with this? Okay, now go. I'm at undefined. I stopped here. So now we're going to have -1, 0. Okay, so then we're going to have -1, which is down here, which is halfway between. We would pi over 4, so now we're at 3 pi over 4. You can label that if you want. And you're down here at -1. Okay, so what do we do? -1, what's our next tangent? At pi, what should I be? Look at pi. Where are you at pi? 0. Okay, go to here. Down here at 5 pi over 4. Between pi and 3 pi over 2, where are we? 1. So let me show you what they look like. Look up here and watch me draw it. Do you guys remember the cubic graph, x cubed? It's kind of like that. But look, it's not a straight line. It approaches that number. Right? I'm going up to the right and down on the left. Do me a favor, look at your unit circle and see what tangent is there between 3 pi over 2 and 2 pi. So here's 3 pi over 2, here's 2 pi. What's easy to graph? This this one. Where is it at? Negative 1. Do you see it now? Up to the right, down to the left. Up to the right, down to the left. And you can, now, okay, put your pencils down and just listen to me for a second. If we marched our way around the unit circle, look what we're going to get. Watch. Ready? 0, 1, undefined, negative 1. Let's check it. 0, 1, undefined, negative 1. Do you see them march around? Does that help you see it? Okay. Now then, we're going to change gears. Go back and find, what do we got first? Sine and cosine? Sine? Okay, go back and find your sine graph. Go back and find your sine graph. I have one somewhere. Ha. That's what we graphed, correct?
Yeah.
Oh, I realized I forgot to fill in domain range on tangent. I'll do that in a second. Now, we've graphed them. You're done. Let me tell you, when you graph sine, cosine, and tangent, the rest of the work is done. It's easy. Now, I do have to show you how today, but it's not hard, okay? First of all, you have to realize, what does cosecant mean? What's it the reciprocal of? 1 over what? 1 over sine of x. Isn't that the same thing? Agree? Okay. Now, I'm going to write all over my paper, but you do not need to do that on yours. I'm just going to do it for teaching purposes. So, let's first of all set up our graph. Make your 9 marks. And label your stuff. And I'll show you how to do this. The outcome for these points right here that we plotted, and they're over on the board there, but since I'm recording, I'm going to write them up here too. X and Y. Our input was 0, pi over 2, pi, 3 pi over 2, and 2 pi. That was our input for sine. Our output was 0, 1, 0, negative 1, 0. Agree? So now then, if I want 1 over sine, okay, so I wanted to find cosecant at 0, and the answer was 0, right? What is 1 over 0 then? What do you think 1 over 0 would be? I should probably use a different color. What's 1 divided by 0, guys? Undefined. So up here at sine, I was at 0. But when I flipped it, what did I get? Undefined. So down here at cosecant, I'm undefined. Let's go to the next point. The next point on here is I input pi over 2. What did I get out, guys? You gotta follow me or I'll lose you. Okay, ready? I input pi over 2. What was my answer? 1. Okay, then so pi over 2 is where I stopped. Sine was 1. Well, cosecant is the flip of sine, so it's 1 over 1. Still 1. It didn't change. It's not negative 1, it's still what? Still 1. Okay? Go to the next stop. What's my next stop, guys? I can follow it here. I'm at 0, and then I've got it over here too. Notice that my hands are in 2 spots. Here it is. I put in pi, I got 0 out, and here's the point. Pi 0. You see it? What if I take 0 and I have 0 over 1, I flip it and I put 0 on top? What is it going to turn into now? Oh, I didn't flip it, I'm sorry. I have 0 over 1, I forgot to flip it. So it turns into 1 over 0. What is 1 over 0? undefined. I'm not doing anything, am I? Other than looking at the picture. You try to go to the next one. You try 3 pi over 2. Here it is on the graph, and here it is the point. I plugged in 3 pi over 2, I got out, my sign is -1. What's the reciprocal of -1? 1 over -1. What's the value? -1. So you're down here. It didn't change. 1 divided by 1 is still 1 divided by 1, right? Go to 2 pi. 2 pi is 0. What's the reciprocal of 0? We've already decided.
1 over 0.
Undefined, 1 over 0. See how having the other graph really makes a difference? Now go the other way. You ready? At negative pi over 2, I was at -1. I'm going to stay down here at -1. At negative pi, I was at 0, so now I'm undefined. At negative 3 pi over 2, sine was 1, so the inverse is still 1. And at negative 2 pi, is that 0? The inverse of 0 is undefined. Now that's not a very good graph, is it? It's kind of like tangent, right? But it doesn't look like tangent. Okay? It actually looks like the exact opposite of what the graph looked like. So here you'll notice this was, okay, watch, and you'll see this a lot better. This is a hill. See the hill? So put your finger on this point. Instead of a hill, you're going to make a valley. I'm going to turn it upside down. Watch, ready? Put your point on the next point right here. This was a valley. What do you think we're going to make? A mountain. But it goes down. Put your point and go down. Okay, over here, match it up. I've got a valley. I'm going to make a hill. And then the last point, what do I have? I've got a hill. I'm going to turn it upside down. Does it look okay? Sure, right? Why not? Okay, let's fill in the domain and range. What's the domain? How far out can we go? Come on, bear with me. Come on, what's the domain? Look. It's all numbers, but what? Where's there a problem? There's lots of problems, isn't there? Where am I not allowed? But we have them all written down, so don't even worry about it. Right? All real, and x cannot equal what? 0. Where else? Positive and negative pi, put both on there all at once, it's easier. And positive and negative 2 pi. We're filling in the graph for cosecant. Find your notes from yesterday. Okay, the period is how far around the unit circle you have to spin to see the pattern. 1 pi is not going to get me there, right? That's a valley. I need to keep going so I can tell sometimes they are mountains. So how much around the unit circle do I need to go? All the way around. That's right. Now for the range. Okay, I don't know if you remember the range is the y, right? We know that. How high and how low can I go? I see arrows up there. How high am I going? Very good. Do you see that window right down the strip in the middle? Look, nothing's here, is there? And when we write range, we start from the bottom and we sweep all the way up, right? So what's the lowest value? So you're going to say negative infinity all the way to -1 and close the bracket. Okay, and put a little U symbol, that's and. I don't have room to fit it. This goes in this little space right here. And then where did we made a hop. We were at -1. Where did we hop up to? Come on, where did we hop up to? 1. So 1 all the way to infinity. How about the amplitude? How high and how low? From the x, how high? And from the x, how low? Can you measure if I go all the way up? going, I can't measure. So guess what? No amplitude. You can't find it here. In A. Whenever they go all the way up and don't stop, it's in A. Okay, so that was cosecant. Find your,
Are we gonna finish tan part?
there we go. Go find your cosine graph, please. Is it right there? Okay, now label for me. Give me my 9 marks. Go. Get it all ready. Sorry. Okay, now that you know, now you've got it all labeled, your hot spots and where you're going to start, we've graphed cosine. Have you found the pattern yet? Okay, you just flip it, it's the same. So let's look at your graph and see where you were before. Are you ready? At cosine, look at your unit circle. Here's 0. Cosine is what value? What's the x value at 0 radians? 1. Okay, what's the reciprocal of 1? 1 divided by 1 is 1, and 1 divided by 1 is still 1. It doesn't change. Okay? So then, no big deal. We won't change it. There's 1. Move to pi over 2. At pi over 2, I'm 0. You can check. You don't want cosine. There's pi over 2, cosine is 0. What's the reciprocal of 0? Undefined. Okay, pi. At pi, I'm at negative 1. So now I'm still going to be at negative 1. 3 pi over 2, I'm at 0. So what am I going to do now? What's the reciprocal of 0? Undefined. And at 2 pi, I'm at 1, so I stay at 1. This graph is looking a little bit like the last graph. Kind of strange. Go the other way. I'm at 0 at pi over 2, negative, so I'm going to be undefined. At negative pi, I'm at negative 1, I stay negative 1. And so forth. Finish your graph, please. Yes.
Can you go over how to get the reciprocal again?
Okay. Or for example, in cosine, the points are there, but let me just talk about it for a second. I'm just going to put a few on there. Right? 0 radians, I wanted y equals cosine at 0 radians, right? And cosine at 0 radians, input 0 radians, output 1. Right? Do you agree?
Yeah.
Then I wanted y equals cosine at pi over 2. So I inputted pi over 2, and my cosine value was 0. Okay, go to the next one. What's y equals cosine at pi? Okay, I inputted pi, and what did I get out? Negative 1. You agree?
Yeah.
Alright, so it's a good question. So everybody listen is asking a great question. Tell me again where you got those reciprocals? What he's asking. So when I input, I'm going to do something right here. When I inputted pi over 2 radians, I got 0. There is an imaginary 1 there. We don't write it, but there's a 1. So if I flip it, because I want secant, the flip of cosine, I'm now going to get 1 over 0, which is undefined. So when I put in 0 radians, I got 1. Well, 1 over 1 is still 1. Because I had 1 for cosine, I want the reciprocal, and I got 1. Go down to here, because this is strange, because you think you want to change the sign, right? So, well, let me show you. I put in pi radians. Pi radians gave me negative 1 cosine. So that means I have 1 over 1. If I flip it, 1 over is still negative 1. It didn't change the sign. That's a very good question. Does that make more sense?
Yeah, thank you.
Okay. So that's where they're coming from again. So now, look at my picture. This was a hill. What are we going to turn this point right here down to? Mm-hmm. And it's high. You had a hill, so put your point on here and turn it into a mountain. And at 2 pi, it was a hill. You're going to turn it. And then you can continue. Okay, fill in the domain and range. You ready? What's the domain again? I know I have writing all over it, I'm sorry. So you kind of just have to do the best you can. What's the domain? All real. But x cannot be. Look and see. Hang on. Where is it? Not 0 this time. It's pi over 2 and 3 pi over 2. So positive and negative pi over 2 and positive and negative 3 pi over 2. What about the period? How much does it take a whole? One's up and one's down, so I need the whole thing. So 2 pi. And the range again. Does it have that giant hole down the middle? Yes. So for my range, what are we going to get? What did I do before? I went from negative infinity to negative 1. There's a bracket around negative 1, and I put 0 around infinity. And 1 to positive infinity. Guys, when you graph these normally, you probably should have done a better job with your 1. See how far I spread my 1 out? If I had put my 1 closer and tighter, my answer would have fit. Okay, what's the range? How high and how low? Got that. What's the amplitude? Can I measure it?
No.
Okay, you're almost finished. Go over to tangent and fill these in real quick. What's the domain of the tangent? All real, except what can x not be? All real, x can't equal, just look at your picture. Positive and negative pi over 2, positive and negative 3 pi over 2. The period is different. Does it have 2 different shapes? No, it's the only one so far that didn't go up and down. It's the same shape, so how much do I need? Do I need all the way around or halfway around? What is halfway around in a circle? Good. Good job. So the period is pi. What about the range? There's no hop in the middle of the graph. How about the amplitude? Can I figure out from the x how high I go and from the x how low I go? Can I figure that out? No. So we're going to call it NA. You guys are so close.
One more.
One more. You ready?
No.
Yeah, because you're good at it by now. Okay, mark them off. 9 spots. Okay, guys, if you stop paying attention, we're not done yet. So focus back in. Come on. We're close. This time I'm going to put my ones closer so that the graph fits better. Okay, again, same kind of thing. Are you ready? Look at my picture. At 0, tangent was 0. In fact, you could look if you want. Here's 0 radians, tangent is 0. Go into your unit circle. So what's the reciprocal of 0? Not 0 over 1 anymore, it's 1 over 0. So I become what? Undefined. So at 0, you're going to have a hash mark. At pi over 2, I was undefined. What's the reciprocal of undefined? You're not undefined anymore. You are now 0. At pi, I was 0. What do I become? Undefined. At 3 pi over 2, I was undefined, I become 0, and so forth. Fill it in. We'll check. He's asking what happens to the picture. Don't draw the picture yet. It's not the same. Were they the same in any other?
No.
Okay, let me just ask some common sense here. If they were a hill, they made a valley, right? Well, look at the tangent graph. In tangent, we went up and to the right. What do you think that the reciprocal is going to be? Not up and to the right. Right. It would be down to the right. Okay? Not up to the right, we go down to the right. So when you graph it, okay, instead of going up and to the right, you're going to go this way. Now, tangents up and to the right. Cotangents up to the left. Try to fill in what's the domain. All real x can't be what? 0, positive and negative pi, positive negative 2 pi. Don't forget 0 in there. What's the period of a tangent and cotangent? Pi. It's the range. That's how high and how low. What's the amplitude? Yay! You're finished. You have all 6 true graphs.